A cosmic dance unfolds. 160,000 light-years away, deep within the Tarantula Nebula lies VFTS 102, a blue giant spinning at an astonishing rate. Imagine a star, larger than our sun, whirling at over 1,000,000 kilometers per hour. Discovered in 2011 by astronomers using the Very Large Telescope in Chile. Its extreme speed challenges our understanding of stellar evolution. VFTS 102 is a cosmic record breaker, offering a glimpse into extreme physics. VFTS 102 rotates so rapidly that it is nearing its breaking point. The centrifugal force generated by its spin is immense, pushing its outer layers outward. This delicate balance between gravity and centrifugal force keeps the star from tearing itself apart. Think of a spinning top, its outer edges blurring as it whirls. VFTS 102 is like a cosmic top, its stellar material stretched and strained by its incredible spin. The faster it rotates, the greater the strain, and the closer it gets to a catastrophic end. This delicate dance cannot last forever. Eventually, something has to give. Will VFTS 102 continue to spin at this breakneck speed, defying the odds? Or will it succumb to the immense forces at play, ripping itself apart in a spectacular cosmic display? The most plausible explanation for VFTS 102's incredible spin lies in its past. Astronomers believe that this star was once part of a binary system, locked in a gravitational dance with another star. This dance, however, took a dramatic turn. Imagine two stars, born from the same cosmic cloud, orbiting each other. As they evolve, one star begins to expand, its outer layers reaching out towards its companion. This transfer of material can spin up the receiving star, like a figure skater pulling in their arms to increase their spin. This process, known as binary interaction, is a common occurrence in the universe. In the case of VFTS 102, this interaction was likely extreme, leading to its current record-breaking spin. The details of this cosmic ballet remain shrouded in mystery, but the evidence points towards a violent and transformative past. The interaction between VFTS 102 and its companion may have culminated in a spectacular event, called a stellar merger. Imagine two stars, drawn together by their mutual gravity, spiraling towards each other in a final, fiery embrace. This cosmic collision would have released an unimaginable amount of energy, birthing VFTS 102 as we see it today. Stellar mergers are some of the most energetic events in the universe. They can produce powerful explosions, spewing stellar material into space and leaving behind a single, rapidly spinning star. This scenario provides a compelling explanation for VFTS 102's extreme rotation. The evidence for a past merger is circumstantial but compelling. VFTS 102's high speed and its location near a supernova remnant suggest a violent and dynamic past. This star is a testament to the power of gravity and the transformative nature of cosmic interactions. So what's next for this cosmic fidget spinner? VFTS 102 is not just a cosmic curiosity, it's a beacon illuminating the mysteries of the universe. Its extreme rotation could lead to a spectacular end that could outshine entire galaxies. Deep within its core, the star is forging heavy elements. These elements, which are the building blocks of planets and life itself, will be scattered into the cosmos upon its death. But how will this star die? One possibility is a long-duration gamma-ray burst, or basically, one of the most powerful explosions in the universe. Gamma-ray bursts are brief, intense flashes of gamma rays, thought to be produced by the collapse of massive stars. VFTS 102's rapid rotation could make it a prime candidate for producing such an event. If so, it would provide invaluable insights into the deaths of massive stars and the extreme physics at play. Can we know what will happen next? Predicting the future of VFTS 102 is a daunting task. Its extreme nature pushes the boundaries of our current models of stellar evolution. However, we are not without tools to study this enigmatic star. The James Webb Space Telescope, with its unprecedented sensitivity and resolution, will provide detailed observations of VFTS 102 and its surroundings. This will allow astronomers to study its composition, temperature, and rotation in greater detail, refining our understanding of its past and future. There is also ESO's extremely large telescope. Set to be the world's largest optical and near-infrared telescope, will further revolutionize our view of VFTS 102. Its immense light-gathering power will enable astronomers to study the star's atmosphere and dynamics with unprecedented precision. Why is such a star so important? Studying extreme stars like VFTS 102 is crucial for our understanding of the universe. These cosmic outliers challenge our theories and force us to confront the unknown. By studying their life cycles, we gain insights into stellar evolution, nucleosynthesis, and the extreme physics that govern the cosmos. These stars also play a crucial role in shaping the universe around them. Understanding their demise is key to understanding the cosmic cycle of birth, life, and death. Furthermore, the study of extreme stars has implications for our understanding of gravitational waves, black holes, and neutron stars. All we have to do is keep going. Keep discovering. VFTS 102 is but one thread in the vast tapestry of the cosmos. Its story is a testament to the power of curiosity, observation, and the never-ending quest to understand the universe we inhabit. As we continue to explore the cosmos, we will undoubtedly encounter more such enigmatic objects, each challenging our understanding and pushing the boundaries of human knowledge. VFTS 102, the ballet star, is a reminder that the cosmos is a place of both beauty and violence. If you enjoyed the story of this star, suggest in the comments below what other mysterious do you want me to tackle next. Don't forget to like this video, subscribe, and hit the bell icon to be notified when another outlier is discovered. As always, keep looking up! And thank you for watching.